Welcome back, Precalcsters. Today I'm going to drop some real-life wisdom on you. If you're ever at a party and you're having a good time, just always remember, and I think that everybody here already knows this, but if you eat chicken and pizza and soda and ice cream and cake and you sing a bunch, maybe you'll feel ill. Feel ill. Maybe. Just keep that in mind just as you're looking at stuff. Cool. All right. So continuing on here, we said that they are inverses, and functions can be inverses of each other. I will try my best to not get goofed up on the language, but there's an important distinction. When we give a function and its inverse, I will try very hard to use inverse function. Does the inverse function exist? Because anything can have an inverse, but whether or not it's a function might be a bigger question. Okay, so I don't care which way we go. Do you guys want to do some graphical stuff first or the algebra side of stuff first? Algebra. Okay, so you guys will have to remind me to come back to this. Let's go ahead. Second section. What's up? Oh, was this your homework?
Yeah.
Are these inverses?
Yeah.
Everybody agree?
Yeah.
Okay. Do I need to show it? Because it's pretty much just the bell ringer, right? There. Anybody want to see this one? Okay. Inverses. Hooray. Thank you for that. He does not look great. Cool. Let's do some more stuff. So checking inverses is pretty easy, right? Just check the composition and see if it works. Let's find some inverses. So here we go. Find f inverse of x. Okay. Now, as we do this, there is a pretty set order of steps that needs to happen. Every x, called the domain, and every y, called the range, they do what when we look at functions and their inverses? They switch. Is that new language today, or did I talk about that last week a little bit? Okay. So, as we look at this, we'll see it graphically for sure, and it'll help, but let's just dig right in. Instead of saying, here's all the steps and then do a problem, I think that we should do them simultaneously. So here we're going to do the how to find an algebraic approach to finding an inverse. Algebraic approach. That's going to be our focus here. Algebraic approach. Now, if we had done the graphs first, if we hadn't mentioned the domain and range switching places, that's okay. Keep that in your mind for now. We'll see it very clear when we do the graph here in just a minute that they do indeed just switch places. But let's look at an algebraic approach. So all we're going to do is we're going to do an example where we'll have the problem like the function that we're starting with, and all we want to do is find this inverse. So we're going to have the actual work and then the annotation. And when I talk about annotation, what are you guys expecting it to be? Like, what is an annotation? So these are shorthands.
Or like using those to annotate.
So good thought. I don't know that it's necessarily going to be this. When we talk about annotating something, have you guys ever annotated a book that you're reading? And it's where you make notes on the side as you're reading, right? So it's a pretty valuable tool. Like physically writing and stuff is helpful. We're going to work a problem, and then just as we're doing the problem, we're going to have real detailed, like, hey, here's what we're actually doing. Here's the step. And we'll just have a good solid example with the rules or the steps that we follow simultaneously. So here we go. I'm going to split this into two tables here, or one table with two columns. And let's start with a problem. So here we'll have f of x equals, we should probably do a linear function first. So let's see here. Let's do f of x equals, oh, I love this one. It's a rational function. It's a fraction, x minus 4, and we'll just make it over 3. We'll make it easier. Now, if I said the domain is a set of all, what would you finish? So just in general, forget not this problem. That's a great answer, though. You are correct. The domain is all real numbers here. The domain is a collection of all the what values? X. So if I asked you about the range, would you ever tell me it's a collection of all the f of x values, or does that feel awkward and clunky? Feels kind of awkward and clunky, right? Because you're going to want to tell me that the range is a collection of all the y values. So Right now, we know that f of x is just it is the y value. It's the same thing. Step one, let's make this a little bit nicer to write. Y equals x minus 4 over 3. And I'm going to switch color throughout, and you could organize it nicer than mine will probably be. What did I just do? Replaced something with something. Good. Replace f of x with y. That's step one. That's it. Okay. I will then make sure so that if you're not using different colors, we can separate it. That is step one. Every time, if you're trying to find an inverse function, replace f of x with y. Now, I've made the comment like 4 times already today, but again, we haven't seen the graphs, so I'm just trusting you to trust me. I'm expecting that you trust me at this point. The domain and the range between a function and its inverse do what? Switch. That means all the x's and all the y's switch places, right? So if it was an x, it becomes a y, and if it was a y, it becomes an x. So let's switch them. Let's swap them around. So our domain and range is swapping. I then, anywhere there's an x, I'll replace it with a y. Anywhere there's a y, I'll replace it with an x. So this becomes x equals what? Y minus 4 over 3. Switch. And if we need to be more wordy, we can. X and y. Now the correct statement here would probably say replace every x with a y and every y with an x. Are you guys okay with that 3-word comment instead? Okay. Now it's weird to have a function x equals. Normally we do what? We don't normally have x equals. How do our functions normally look? It's not x equals ym plus, well, I can't even say it. It's usually y equals something, right? Do you think we can somehow make this be y equals? So I want you guys to solve for y, and I'll call that step 3 of this process. Solve for y. And I'm going to let you guys play the algebra game for just a minute. I'm going to take an obnoxious drink of water.
Oh my gosh.
Mr. Holloway, when I walked in, because I can't see that far, I thought you got a buzz. Because your hair's
Yeah.
back.
Oh, sorry. Did we have the samurai
Yes.
talking here?
Yes.
Okay, Holloway Sama today.
Otherwise,
Or Sensei. I'll take Sensei.
reminds me of the Rocket League days. Yeah, it's funny.
Okay, I'm going to do a little bit of scratch work. It's up to you how much of this you want to write down. You're probably doing scratch work anyway. First step, I would multiply each side by 3 to get rid of my fraction. And then I'm going to add 4, and I'm going to switch sides. Do you guys get 3x plus 4?
Yes.
Okay, we have just solved for y. Now, at this point, here's the cool thing. We have the inverse. But you can't tell because I started with f, and now I just have y equals. One last step. If I want it to be very, very clear that I have the inverse, what do you think I should do? How could I write this so it's very clear that it's the inverse? How do you write the inverse of f? So you can say it this time. F, there's an exponent that I'm going to connect to it. So check it out. F inverse of x, 3x plus 4. Walk me through what I just did. How do I say what just happened for step 4?
Write in inverse form.
I agree with that. I'm going to try to match the same language. Replace y with f inverse. That's it. We're done. Cool. Now, once we get a little bit of practice with it, there are some pretty, really, really handy things that we can do because this process, one, I don't think this process is like mind-numbingly difficult, but there are some shortcuts that we can take. Let's do another one. And by let's, I mean together, question mark, or do you guys want to try one on your own? All right. So I should give you a terrible one, right?
No.
So I'm going to give you a terrible one, but you're going to collaborate so that it's not as terrible. This I legitimately think is worse because fractions are scarier than what I'm about to write, but you may disagree with me. Okay, so my notes are going to look silly, but I'm going to go all the way up. Cool. All right, so here's example B. This time, we get f of x is defined as the cubed root, you're okay, of x minus 5. I'm going to give you guys about a minute, 90-second head start. I'll start working it as well, and then we'll come back together and see if there's issues. Where are they? How do we fix them? But I want you guys to work with one another. Find me f inverse of x. And go. Red, if you're watching this, pause the video now and work through this example to the best of your ability, and you will see detailed work in 3, 2, 1. Help me out here. What do I do? Change it to y. So y equals the cube root of x minus 5. Now we'll switch them. X is then equal to the cube root of y minus 5. Cube both sides. X cubed is now equal to y minus 5. I'm going to add 5 and I'm going to switch it again. F inverse of x is then equal to x cubed plus 5. Everybody on cool with this? Yeah. Is this super duper challenging to do? No. Now, here's something that I do want to show you guys. If you try to do them in your head, sometimes it can be really hard, just so you know. But here's what I want to think about. I want to think about if we started with just x, and this is just, I don't have a good way to write this down, so I wouldn't write what's over here, okay? If it's maroon, I don't have a good way to alliterate, but don't write it down. So check it out. If I started with x, and I wanted to build this up, what's the first thing you would do to get from x to this? I now have to add and subtract or do stuff to it, but would I first take the cube root, or would I add or subtract 5 first? So minus 5 would be the first thing, so I'd get to x minus 5. And then what's one more thing that I would have to do? Cube root. Do you guys agree that that's how we would get to the cube root of x minus 5? Okay, check this out. Let's just start on the other end. If I start x and I want to just undo stuff, I'm going this way. Instead of taking the cube root, what undoes a cube root? So I'll cube it, and what's the opposite of subtracting 5? And we can see it happens right then and there, just like this. I just go the opposite direction and I can get it. Now, whether or not this really saves time, I don't know, it depends. But finding inverses seem okay. All right, I'm going to pause and open up Desmos real quick because our next little section is going to be the graphical interpretation of these. We're going to have time for homework in class today. All right. Now, could you just randomly shuffle them? Like, maybe. It's not exactly 0 possibility, but the odds of it happening are pretty much 0. All right. We're going to graph some of these. Let's check. We just graphed the cubed root of x minus 5, right? So I'm just going to use y equals the cubed root, and I'm not going to write it that way. The cubed root is a 1/3 power. Here's the graph of this one. Everybody cool with that? And what was the other function that we got this from? X cubed plus 5? Are these graphs related?
Yes.
They kind of look similar. We had another pair of function and its inverse. I'm going to turn these ones off for a second. What were another pair of f and f inverse that we did? Check your notes. So y equals, you said x minus 4 over 3? Yeah. And it must be 3x plus 4. Yeah. Are these graphs related?
Yeah.
So those are certainly related to each other. These are related to each other. Let's get another one. What if I did y equals x squared, but I told it, hey, let's just chill out here. Let's only pick greater than 0. Like, it seems weird, but maybe there's a reason I could do this. What's the inverse of a quadratic? Huh. They're mirrored. Gosh, if I put line y equals x, does it really truly just look like they're reflected? Well, those two are supposedly inverses, and I'll tell you they are. What about if I pick these two that were also supposed to be inverses? Huh.
Yeah.
Well, let's do this last one. Okay, so it seems like it. Now, I can see graphically how to come up with an inverse pretty easily. They seemingly all just reflect over what line? Y equals x. Now, a reflection over the line y equals x, and there's going to be a mouthful, is just like rotating about the origin by 180 degrees. Blah. I remember in geometry with you guys years ago when we had the scratch paper and we rotated it and we found the rules. You probably don't remember them. Here's the graph. The 0.50 is on this graph. Switch the x and y, and what does that order pair become?
0, 5.
Huh. If I pick 10,
Oh, because they
so we're going to say 10 and 1.7 because I'm not going to get it perfectly. Oh, I did. 10 and 1.7099. I'm never going to find 1.7099, but I'll try. Hey, but it's right here. Hey. Gosh, it certainly just looks like every x and every y did what? Which, when we solve these things algebraically, what do we do with the x's and y's? Swap. We swished and swapped. Which, flip and flop means we get exactly what we're after. I can see all those statements that I just wrote algebraically happening on the graph. Every single time. Now, couple really important things that we have to pay careful attention to when we're thinking about a function and its inverse. So we're going to summarize those first couple really quickly. And we have 5 to 10 more minutes is my guess. Okay, so we talked analytically. Let's talk last little part of 1.9. Hey, we're already at 1.9? Awesome. Graphical interpretation. Now, I don't think it's a surprise. Interpretation. I 100% don't mind graphing. Like, I'm okay with graphing. You guys maybe don't love it as much. And I'm going to be honest, I don't really love it because it's kind of tedious. But the graphical interpretation is super handy, just like the algebra interpretation is super handy if you don't want to have to graph it. They're both useful in their own way. So, let's take a look. First thing, I'm going to use a tilde to separate this. F of x and f inverse of x are simply reflected, and I'm just going to say just because it's shorter, reflected over what? Over the line y equals x. Now, the important thing about y equals x is that, gosh, the function just y equals x or f of x equals x is called the what? It is a parent function of the linears, but there's a bigger name for it. Identity.
Oh.
It's the identity function. We're seeing the identity naturally show up here as well. So as we look at this, here's one very important interpretation. Now specifically, and I'm going to say e.g., if a comma, and I'm going to write this differently, if f of a equals b, which I just want everybody to notice, what did I plug in for x? And it spit out this, so this is my ordered pair AB. It's just written in this form. If f of a is equal to b, then if I were to take f inverse of b, what should it spit out? A. The x and the y, they just switch places. And I can see it. It becomes really handy to graph these or to evaluate them if we don't have it. Okay. As we're dealing with these, earlier I made a comment right at the beginning about how I'm going to misstate things, and I won't say the inverse function. I will try very specifically to find the inverse function. Don't draw this, but I want you to help me figure out where the issue is. So I'm going to graph x squared is a function. Everybody agree? Okay, so here's roughly the graph of x squared. Everybody okay that that's pretty much x squared? Now, if I wanted to, say, graph the inverse, I would just simply draw an extra line, and then I would try my best to reflect it. What's that line that I would draw? If I want to graph the inverse, it's just a reflection over something. Okay, would you believe that I said that if this is y equals x?
Yes.
So if I try to reflect this, I just want to see something. I know that that part would be like that. That part would just kind of keep going out like this, and it's not going to quite go that far. Look about like that. Does that look like it's reflected?
Yeah.
And then this one, it would reflect over about like this.
No.
I think so.
Yeah.
This, if this was -1, 1, this is 1, -1. Okay. This blue one, the inverse that I just tried to graph. I can call it an inverse. I'm fine with that, but I cannot call it an inverse function. Why? How come? The negatives aren't as much as my concern. There's, hey, it fails a vertical line test when I try to do it with the blue one, right? So the inverse is no longer a function, which is an issue. Question or just moving? Okay. Sorry, I just got the movement out of my peripheral. So here we go. We have a really big idea called injectivity. Now, injective is a fancy word that means something very specific. Not going to lie, normally we don't see this word in the high school classroom because we use a very similar one. You probably don't remember the word injective, but you remember one-to-one. Okay, some of you might. If you don't, that's okay. And function is injective, or one-to-one, if for every y value, there's only one x value. Now it's backward. For example, this red function, if I wanted to pick this y value at 5, for example, how many x values spit out that? If this is 5, you agree there's 2 points that spit out that. Okay. Was there a one-to-one ratio between y and x then? There were 2 x's that spit out that same y, right? So it's not one-to-one. They have to be in a one-to-one correspondence. For every y, there's one x. Here's the big takeaway and why we're talking about this. For f, for the inverse of f of x to be a function, f of x must be one-to-one. Now, I'm going to write injective because that's the real formal language, but here's the deal. You can write one-to-one, and realistically, I'll normally use one-to-one. I just wanted you guys to know the word injective. When I actually draw it, I just draw a little TIE fighter. One-to-one, 1-1. Okay, for the inverse of f to be a function, f of x must be one-to-one. Now, that might not mean a ton to everybody because it can be hard to think about, is there more than one y value connected to this x? There's a really, really easy way to test because we're talking about things graphically, right? Check it out. This injective, I'm going to make a big asterisk. There's a play on words waiting in there somewhere eventually. I like it. Injective, one-to-one, one-to-one, if the graph, and I'm going to write down passes, and I want you guys, before you write it, I want to make sure that we can all agree what this means. If it passes HLT, it's one-to-one. I don't know if you guys have ever seen the HLT, but I know you've all seen the VLT, and VLT stood for what? Any thoughts on what HLT stands for? Horizontal line test. If a horizontal line touches more than once, you've shown me that there's 2 y values that connect to a single x. That is not a one-to-one correspondence. They have to pass the horizontal line test. When I looked at this one, and I'm going to come back over here, notice I did some weird stuff with x squared, right? So this is not just a graph of x squared. Not quite. Why did I restrict it here?
Because if you let it keep going, you get into a parabola.
If I don't restrict the x's I can use, does this thing pass the horizontal line test? No, any horizontal line you ever give me, y equals 2 for example, I can see that for this y value, there are 2 separate x's that spit it out. That is a 2-to-1 ratio or correspondence between x and y. I need it to be 1-to-1. We might have to sometimes restrict our domains in such a way that we only allow parts that make it 1-to-1. It makes it super duper easy to see. Okay, do you want to glance ahead at where we're going to see this again and really care about it? Good, because you're going to get it anyway. Is this 1-to-1?
No.
Convince me. A horizontal line touches more than once. Okay. Is there a section of it that it is 1-to-1?
Yes.
So you're probably not super up to speed with all your trig stuff, and that's okay. What if I did from negative, I don't know, pi halves to pi halves.
There you go.
Is that 1 to 1?
Yeah.
And you guys have already seen a little bit of this trig stuff. Like that one does pass the horizontal line test now. Is there an inverse to sine?
Cosine.
Not cosine. Arc sine or inverse sine? It's the second sine button on your calculators. I guarantee you saw it last year. In fact, I guarantee you saw it in my geometry class several years ago as well. Inverses exist so long as we're careful. Okay. Boom. I think I'm good with this. Okay. Just to be really clear, and maybe to make it less clear, so I won't even say it. All right, we cool here? All right. So I'm going to let you guys help me make a decision real quick. There's one more section in the notes. You all took science with me. Nobody took physics last year. We're going to do a modeling section as well. Not like Vogue modeling, but modeling as in how do we write equations for certain situations. I'm going to let you guys pick. Is that something you want to show up on the test, or do you want to do a standalone section?
What do you mean?
I'm really asking, do you want to do 1.10 tomorrow and then do the practice test and testing Wednesday through Friday? Or the alternative would be we can take practice test tomorrow, knock out the test, and then we'll look at the modeling section alone. Do you want one more section on your test is the big question.
No.
So with that, you understand that if that's the route we go, the test would be when? The practice has to be tomorrow.
Our practice test graded.
Yeah, I grade them, but we'll talk.
Like how is it?
Okay.
Basic.
One less section is always better, right? Okay. So here's the deal. Tomorrow in class, we're going to take a practice test. But we'll talk at the end of the hour about what that will look like. For today, gosh, I wonder if I have this here yet. Come on. Nope. All right. Tonight, you guys get almost 20 minutes right now to work on assignment. It's pretty sweet. Remember, I'm not posting the videos to, I'm not putting the links in here anymore because it's just tedious. Whoa, that's not lesson. I'm all goofed up here. Oh, it's because we're on 1.9. Lesson 1.9.2, finding inverses. Your homework will be homework 1.9. And you will find this waiting for you on page 90. And you get questions 1 through 6, 17, 21, 23, and I would, underneath that, I'm going to write algebraic. I don't know why I have that, but I have it on mine, so it must mean that it's going to ask you to graph it and stuff. I don't care about the graph. I just want you to find it. And then 45, 51, 87. 41, 55, 87. Okay, 21 and 23. And I'll put this up here before I quit the video so that you guys, I need somebody else's book though. Hey, Wishes is open. Okay, there's actually a couple things I want to show you in here. If you don't want to take your book home and you don't have digital access, which I don't know why that would possibly be the case because we have digital access, I'll do a quick scan of the problems. You guys are going to have to help me because mine are going to disappear. So 1 through 6. So we'll focus. Okay, so there's 1 through 6, and then we went to where? 17. So 17. So sketch the graph of the inverse. There's an easy way to do it. Even without knowing what the function is, you can sketch it. And then we go through 21 and 25. Okay, it says verify that they are inverse functions. Do it algebraically and graphically. For 21 and 23, I don't need to see the graphical version. Just do the algebra. Check your compositions. Okay, and then from there we go to 45. 41. Okay, so apply the horizontal line test. Use your calculator, or I would do this one in class before you go. Use a calculator. Tell me if it passes HLT to see whether its inverse is a function as well. Okay, so there's 41. 51?
55.
Weird, I got mixed up in my head, but that's okay. 55, it says, hey, find this. Domain and range of f and f inverse, I'm going to be chill about, because that's a harder question. So there's 55. And this is just for, I was doing this for red, but I forgot we had textbook. And 87, that sounds neat. Oh, do the composition and then find the inverse? That's pretty neat. All right, so talking about the practice test, team test. Bless you. Okay, the way, if you guys don't remember, I'm pretty sure I did this with you guys. We are going to take an in-class team test tomorrow. We have 11 people in here. That seems like a couple teams of 4 and a team of 3. I'm cool with that. In class tomorrow, I'm going to have you attempt to the best of your ability to work through this with or without a note card and your teammates. Okay, because this is the first one of the year and we're, I think, getting back into the swing. I feel like we're pretty much in the swing of things at this point. If we have to take it home, I'm okay with that. But if you finish it in class, I'm also cool with that. While you're studying for stuff, if you haven't made use of your textbook like a lot yet, I'm just flipping forward a few simple pages. These books, is this Larson? Ron Larson's the man, just for the record. No idea what he looks like, but he's like one of the better textbook authors that I've ever encountered. Here is all of the main ideas that you've seen in every section. This is on page 104. If you were to make a note card, and I'm not requiring it, I'll let you guys use note cards on the first one if you want. Here is everything that I would put on my note card. I wouldn't actually put all of this, but anything that could show up on your note card, I would say is pretty much in here. Okay, minus 1.10. We just won't put that one on here. Okay, if you're feeling super ambitious, I'm pretty confident, it's been a few years since I've written these, but I'm pretty confident that every single question on the practice test and the test comes out of these review exercises. So if you're thinking, gosh, you know what, I'm going to get you, Holloway, I'm just going to do all 103 of these so that I know every problem. Good, do it. I dare you. Cool. All right. I will pass out note cards. Tomorrow, honestly, I think you'll probably wind up taking the practice test home. So here's what I'm going to propose. Let's not focus on note cards tonight. Okay, tomorrow in class, whether I'm here or not, I want you guys in groups working together. And then if it has to go home, it will. But I'm going to ask that if I'm not here when you're working through it, do as much of it as you can without your notes. Circle the problems that you didn't finish without them so you know what is the most important stuff to put on your note card. Cool. All right, I'll let you guys get to it. I'll give Weisha back her book. I'll go high five Lay.